Okay, ladies and gentlemen, let's go over study guide for Unit 3 test. Again, this is Advanced Algebra through Data Exploration. All right, let's take a look. Number 1, an article on Honda in Consumer Reports 1990 reported the following average miles per gallon. Number 1, construct a stem and leaf plot of the above data. All right, you need to remember a stem and leaf plot. This is where we draw the vertical line. The stem will be on the left. The leaves will be on the right. We look at what the smallest number up there is. The smallest number is 18, so that means our stem is going to begin with a 1. We need to look at the largest number up there. The largest number is 50. That means we need to go to the number 5. So 1, 2, 3, 4, 5. Now we need to fill in the leaves. So we will start with the 18. So the 8 will go next to the vertical line. So we are done with anything in the teens. Now we're going to look at the 20s. So it looks like the smallest 20 is the actual number 20. So we're going to put a 0. The next number in the list is 22, so we'll put a 2. The next number in the list is 23, so we will put a 3. The next number in the list is 5, so we will put a 5. All right, that's it for the 20s. Now we're going to do the 30s. So the smallest in the 30s is 30, so 0. Again, try to line your digits up nicely. Then we have 32. 32. Then we have 33. Then we have two 34s. Then we have 35 and 36. All right, now the 40s. We have two 40s. We have 41, and then we have three 42s. Again, line your digits up nicely, please. And then the last one we have is 50. All right, now remember, we're not quite done because you need a key. If you forget that on the test, you will lose a couple of points. The key tells us what we are looking at. So again, you can pick any number. I'll just pick the first one and put 1 with a vertical line. 8 equals 18. And what does that 18 mean? Miles per gallon. So the person looking at your display can easily identify what it is they are looking at. All right? Now, for this next part, construct a box and whisker plot. This is where we are going to want to have the calculator give us a hand. So I'm going to erase my marks up here, and we're going to need to type this into the calculator. All right, so let's go through the calculator steps, which I expect you to remember on your own, so you better practice this. All right, here we go. So we pull up the calculator. Okay, and we hit Stat. And we hit number 1, Edit. All right, now I've already typed the numbers in to find time, but let's review how to delete. So I will show you this with list 3. So remember, you go to the top, you hit Clear, and then you hit Enter. Never, never hit Delete. All right, so you go to list, so you should have done that in list 1. Okay, now if your list 1 is missing, then you're going to have to put list 1 back. All right, or switch calculators. All right, so I've already typed them in, so you may want, again, at any time, you may need to pause the video while you type them in. This might be a good place to pause the video. But I've already typed them in, so I'm going to continue. All right, so all the numbers are in list 1. Now, I'm going to make my number line before I make my box and whisker plot. Very important that you make the number line first. Now, in my data list, it begins with 18 and it goes up to 50. And I'm going to count by fives. So what I'm going to do is I'm going to start with 15. Again, don't start with 18. You need to go below 18. So I'm going to count by fives now. So that's going to be 15, 20, 25, 30, 35, 40, 45, 50. Okay, I need to go up to 50. Now remember, when we draw the box and whisker plot, we need to draw it above the number line. Do not draw it on the number line. If you do, I will take some points off. All right, so now we're going to have the calculator do that for us. So we've got our numbers in. Here we go. So we're going to go Stat, right arrow to calculate, pick number 1. If you have an old calculator, you just have to hit enter once. If you've got a new calculator, you will have to hit enter 3 times. Okay, once you get to this screen, remember you got to scroll down with the down arrow to find the 5 numbers we need for the box and whisker, and there they are. Okay, I'm going to read through them, and then I'm going to mark them and make my box and whisker plot. So the minimum is 18, Q1 is 25, the median is 34, Q3 is 41, and the maximum is 50. All right, so let's go make our box and whisker. So we're going to mark the minimum, 18, which is right about here. Please write the number above. Q1 is 25. I'm going to mark it right here, 25. The median is 34. I'm going to mark it right about there, 34. Q3 is 41, right about here. And the maximum is 50, right there. All right, so remember it begins with a whisker and it ends with a whisker. And then the middle, there is your box. All right, there is your box and whisker plot. Okay, so number 3. It says find the mean. Well, guess what? We already found the mean. So let's go back to the calculator. Let's scroll back to the top. It's the very first line. The X with the line above it, called X bar, that is our mean, 33.6. All right, the mode is the one that occurs the most. Okay, well, the easiest way is to look at our stem and leaf plot, and you will notice the one that occurs the most is the 42. The 42 occurred 3 times, so the mode is 42. The range, that's where we got to do a little bit of math. You take the maximum, which is 50, minus the minimum, and so the range is 32. Now, remember the IQR. Here, let me do this first. So I took the maximum minus the minimum. Now, for IQR, remember that means interquartile range. That's where we take Q3 minus Q1. And we have the display right above us. And you see that Q3 is 40 minus Q1, which is 25. And so, therefore, the interquartile range is... Oops, I did that wrong. Let me back up, please. Okay, sorry, it's 41 minus 25, which is 16. Okay, sorry about that. Make sure you get the correct interquartile range. So that's page 1. Page 2, please. All right. Use the picture to answer questions 4, 5, and 6. All right. What is the dot called in the picture? It's right there. Okay, you should remember, and these are some terms you need to know, that is an outlier. Remember, an outlier is a number that does not fit with the rest, and when you display it in a box and whisker, it shows up as a dot. It's way different than all of the others. Now, which side of the median Which side of the median would the mean fall? Okay, well, the median is the line in the box. Now, on what side will the average, remember mean is the average, what side will the mean be on? Well, the outlier is pulling the mean in its direction. So that means the mean is going to be on the left side. And I just gave the reason. The outlier pulls the mean down, which is causing it to move it to the left. Which way is it skewed? Well, it's being stretched to the left, therefore it is skewed to the left. Okay, next problem. This was in one of your packets, and I told you you have to have this memorized. Okay, first of all, each piece represents 25% of the data. Always, that will never ever change. That is just a fact you need to have memorized. Label the 5 parts. Okay, well that's pretty easy. Minimum, Q1, median, Q3, and maximum. Okay. Next question. We already answered it. What percent is each piece of the box plot? 25%. Number 9. If the box plot represents 80 values, how many values are in the lower whisker? All right, well, the lower whisker is 25%. The decimal for 25% is 0.25. So we take 80 times 0.25, and that's going to tell us how many numbers are in the whisker. So, and if you do that with your calculator, you should get 20. So there are 20 values or 20 numbers that represent the lower whisker. If the box plot represents 50 values, how many values are in the whole box? Well, first of all, the whole box is 50% of the data. The decimal for 50% is 0.50. So, just like what we did on number 9, we're going to take 50 and we're going to multiply it to 0.50. Well, that would be half of them. So that would be 25. So, if there were 50 values represented in the whole box and whisker, 25 of those 50 would be the box portion of the box and whisker. Okay, again, at any time you need to repeat, just rewind it a little and listen to it again. Okay, the next page. Now, you do not have to type any of these into the calculator. I've already put the picture up for you. You have to interpret it. Let's read through it. Face it, a hot dog isn't a carrot stick. So said Consumer Reports, commenting on the low nutritional quality of All-American Frank. Because people are concerned about their health, may prefer low-calorie hot dogs, we ask. Are there any systematic differences among the two types of hot dogs? Use the box plot to help answer the question. So, the meat hot dogs, that's already displayed for you right here. The poultry hot dogs, that display is right there. They're labeled, and there's a number line underneath. And all of these numbers represent the calories for the hot dogs. Okay, and the picture is already displayed for you, so there's no reason to type these into the calculator. We're just looking, can you see something? So the question is, what does the data show about the two different hot dogs? Well, you can word this in a number of ways, but this is what I see. The meat hot dogs have more calories than the poultry hot dogs. Or you could reverse that and say the poultry hot dogs have less calories than the meat hot dogs. Okay, but that's all I'm asking you. Look at the picture and tell me what you see. That's part of data analysis. All right, next picture. Use the picture to answer questions 12 and 13. First of all, which side of the median would the mean fall? Okay, so we don't know exactly where the median is, okay? We're not sure. The median might be right here. We're not sure, but we really don't care because what we learned, okay, about how it is skewed. If you look at the picture, you will notice it's being stretched to the right. Okay, it's being stretched to the right. Now, the direction it's being stretched is the direction that the mean is going to get pulled. So that means the mean is going to be somewhere. We don't know where. Okay, it doesn't matter here. It's going to be somewhere on the right. So we're going to say it falls on the right side. Explain. The graph is skewed to the right, which will pull the mean to the right of the median. That will always be true. That will always be true. And we already answered this. Which way is it skewed? Okay, well, it's skewed to the right. So when you're taking the test, make sure you're looking at the picture carefully because I may have it skewed to the left. You have to know what it means to be skewed. All right, let's keep going. Next page. We're going to have to make a histogram. And again, I recommend not using the calculator. Not using the calculator. This histogram does not have all that many numbers, so it's pretty easy. Now, the first thing we need to do, however, is identify how we're going to make the number line for our horizontal axis. So we need to identify what's the smallest number? 22. What's the largest number? 60, it looks like 65 is the largest number. Nope, 68. 68 is the largest number. So, I believe it would be easiest to count by tens. You certainly could count by fives, but counting by tens in this situation is sufficient. So the corner is always 0. Okay, the lowest number is 22. But I'm just going to go ahead and I'm going to just go by 10. So 0, 10, 20, 30, 40, 50, 60, and I must go up to 70 because the biggest number is 68. Okay, so I'm going to put my numbers in now. 10, 20, 30, 40, 50, 60. Now, the frequency is how many numbers there are. And again, most of the time you count the frequency by ones. And that's what I'm going to do here. And I'm going to count up to, it looks like I should go up to only 5. 1, 2, 3, 4, 5. Okay, so now I'm going to start making my histogram. First of all, are there any numbers from 0 to 10? No. There's no bar from 0 to 10. Are there any numbers from 10 to 20? No. There are no numbers from 10 to 20. Are there any numbers from 20 to 30? Yes. 1, which is 22. So I'm going to go up, over, back down again. And I'm going to put a 1 there. Okay, normally we don't do that, but you can put a 1 there. That means there's one number from 20 to 30. Are there any numbers from 30 to 40? Yes, there are some numbers from 30 to 40. I believe there are 4 of them. So I'm going to cross them off. So here's 36, 39, do not include 40, 30, and 30. So there are 4 numbers in the 30s. So I'm going to go up to 4, over, and back down again. So there were 4 numbers in the 40s. I mean 30s, sorry. There were 4 numbers in the 30s. Now I'm going to look how many numbers are there in the 40s. Okay, so I'm going to count all of the 40s. 1, 2, 3, 4, 5. There are 5 numbers in the 40s. So that means I'm going to go up to 5. I'm going to go over, back down again on the 50. There were 5 numbers in the 40s. How many are in the 50s? Okay, it doesn't look like I made my frequency high enough here. So let's count. In the 50s, we've got 1, 2, 3, 4, 5, 6, 7. Okay, I need to make my frequency a little higher here. 6, 7. So there are 7 numbers in the 50s. So I'm going to go up to 7. Up to 7, over, and back down again. All right, and how many numbers are in the 60s? Okay, it looks like there are 3 of them, or 2 of them. Yep, nope, 3 of them. 1, 2, and 3. Over, down. All right, there is my histogram. Again, I would not try to make that on the calculator screen. Okay, it's a lot easier just to do it by hand. All right, moving on. Use the histogram to answers 15 through 20. Okay, so this histogram is showing minutes spent on the bus. How many people does the histogram represent? Well, the first thing I would do is go and label my bars. So there's 2 people here. There's 10 people here. Looks like 5 people here. 2 people here and 1 person there. So how many? So we add them up. 2 plus 10 plus 5 plus 2 plus 1. And I believe we end up with 20. So this histogram is representing 20 people. What percent of people ride the bus 10 to 20 minutes? All right, well, that's where we have to make a fraction. So there are, right here, let me color code this. This is the 10 to 20 minutes. There are 10 people out of 20. Well, that's easy. That's 50%. What percent of people ride the bus more than 30 minutes? All right, so more than 30. Let me change colors here. Let me go with green. That would be this and this. So more than 30 would be 3 out of 20. Okay, now the decimal for that is going to be 0.15. And so the percent would be 15%. In what interval is the median time? Okay, well, median, let's go with orange here. Median is the middle. All right, so, median is the middle. Okay, well, there are 20 numbers. If I divide that by 2, I get 10. But that 10 is not the middle. It would be 10 and 11. That's the middle, the 10th and the 11th. All right, so let's take a look. So we've got 2 people here. And then here's the 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th. Oh, okay, one more, 11th. So the median is in the interval from 10 to 20. If you were to find the mean, would it be smaller or larger than the median? Okay, here we go again. So we're going to look at which way is it skewed. So if I do this, I notice it's being stretched to the right. So it's going to be to the right. Why? Okay. The graph is skewed right, which means the mean is to the right of the median. Okay, again, the graph is skewed to the right, which means the mean is to the right of the median. Number 20. If a person riding the bus is in the 80th percentile for time, at what interval will the person be? Okay, so 80th percentile. Remember, we changed that to a decimal. Now, there's 20 people riding the bus, so we need to figure out where that person is. Where does that person fall? So we take 20 times the 0.80, and we get 16. So we are looking for the 16th person. The 16th person. Okay, well, this bar had 2 people. This one has 10 people. Let's see, I need to draw one more there. So that's 2 and 10 make 12. Okay, 12. And I want the 16th. So 12, 13, 14, 15, aha, 16. The 16th person is in here. So the 16th person falls in the interval of 20 to 30. Again, think about what we did there. We changed the 80th percentile to a percent, multiplied it to 20. We found that that was the 16th person. So then we had to count in our histogram to the 16th person. All right, next page. Okay, so on the test, this is what it's going to look like. You have to be able to follow the steps. You have to read each step very carefully. Okay? So 21 says find the mean absolute deviation. Use the table to help. All right, here we go. First of all, find the mean of the numbers. Okay, I'm not going to actually go through this with the calculator, but I'm going to talk about the steps. So remember, go to your stat, edit, clean out list 1. Type the numbers in list 1. When you're done typing the numbers in list 1, go stat, calculate, and pick number 1. Okay, when you are all done, you are then going to see the mean at the top of the screen. All right, now I've already done this, so I'm not going to go through it again. Again, type them in list 1. When you're done, you're going to go stat, calculate, and then do number 1, the one variable stats. The X bar is your mean. Okay, for this problem, the mean is 28. Now, the first column is for the numbers. So here we go. So I'm just going to copy the numbers down this column. The middle column, which I didn't leave much room for, you are going to do the subtraction. So you're going to take the 30 minus the mean. Then the 28 minus the mean. Okay, I'm just going to write these down and you follow. Or you pause it and do it yourself. Okay, now I'm going to do all of the differences. Okay, that was step 2. The middle column was for step 2. The third column is for step 3. Find the absolute value of each difference. Remember, absolute values are just the positives. Step 4, find the mean of the absolute values. Okay, well, you have two choices. You could go ahead and put these in list 1. And then you could do the same thing here. You could do the stat calculate number 1, and the calculator will tell you what the mean is. But you're going to put the new values in list 1. Or you follow these steps. Okay, you don't have to do it that way. So the first thing we're going to do is we're going to add all of these numbers up. So 2 plus 0 plus 0 plus 1 plus 6 plus 10 plus 8 plus 4 plus 2 plus 1. That's going to add up to 34. Then we're going to take the 34 and we're going to divide it by how many numbers there are. There are 10 of them. And we're going to get 3.4. And that's the answer I'm looking for. So that is the mean absolute deviation. Okay. The next one's almost the same, but you'll notice some of the steps are slightly different. So we already use these same numbers. Okay. So we already have step 1 and step 2 done. Okay, but step 3 is what's different. Okay, this is where it's going to change. So don't do exactly the same thing. So I'm going to go ahead and I'm going to write down column 1 and column 2 just to match the first one. So here we go. Okay. And then the differences, again, it's the same numbers, so let me put that in blue. So here are the differences. Now on the test, you may not have the same numbers, so you may have to find all of those things again with different numbers. All right, now step 3. Step 3. Step 3 is different than what is up above. Square the differences. Okay, so 2 squared is 4. 0 squared is 0. 0 squared is 0. 1 squared is 1. Negative 6 squared is 36. Okay, negative 10 squared is 100. 8 squared is 64. 4 squared is 16. 2 squared is 4. Negative 1 squared is 1. Okay, you square the numbers. Square those differences. And when you square them, they all should be positive. Now again, you can follow the same steps if you want to find, to find the mean. Well, no, actually we got to do this different, sorry. We have to do it this way. We have to find the sum of the squares, so we're going to add those all up. Again, I've already added them up, and they add up to 226. Okay, so the sum is 226. Then we're going to divide the sum by 1 less than the number of numbers. Okay, well, we're going to take the 226. Okay, there are 10 numbers. 1 less than the number of numbers. That means we're going to divide by 9, not 10. Okay, and when we do that, we get 25.4. So the last step is to take the square root of the number you got in step 5. So we're going to take the square root of 25.4, and we are going to get 5.01. That is the standard deviation. And that is what we're going to be using a lot in the very last unit in this course, in Unit 10. Okay, look at it again. Make sure you practice it. The steps are in front of you. The steps will be listed on the test. You just have to follow them. Okay, number 23. Look at the two data sets. Which one will have a higher standard deviation and why? Okay, you do not need to type these into the calculator to know the answer to it. What you're going to do is you're going to look at the highest and lowest number, okay? So in this data set, the lowest number is 18. The highest number is 23. There's not that much difference between 18 and 23. In this data set, the low number is 8. The high number is 31. Okay, well, data set 2, okay, oops, set number 2 will have a higher standard deviation because the low number and high number are further apart. Okay, they're more spread out. More spread out. Another way to think about that is there is more variability. Okay, because we've used that term before. You do not need to use a calculator for that. You just have to look at the numbers. All right, let's wrap this up. 20% of your test is going to be based on the review section. And this is what the cumulative review section looks like for your test. Again, this is 20% of your grade. All right, so number 24. Solve the unknown angle measure in the diagram below. All right, so we can see that this first angle is 24 degrees. Let me rewrite that. This is 24 degrees. This angle up here is 21 degrees. And we want to know what this angle is. Okay, well, we know that the angles of a triangle add up to 180. Okay? The angles in a triangle equal 180 degrees altogether. Well, I'm going to find this missing angle first. And I notice that that angle is obtuse. Obtuse means more than 90 degrees. So I need to find out what that angle is. So what I'm going to do is I know the three angles add up to 180. So what I'm going to do is I'm going to take 180 minus the 24 degrees minus the 21 degrees, and that's going to give me the other angle. Now, that angle is 100. What's left is 135 degrees. So this angle is 135 degrees. Well, these two angles are supplementary angles. And I know that supplementary angles add up to 180, also 180 degrees. Well, all I have to do is go 180 degrees minus 135, and so the missing angle is 45 degrees. Okay, so the important thing there was remembering triangles, the angles add up to 180, and then supplementary angles also add up to 180. So to find that missing angle, you had to show all that work. All right, number 25. Same thing, we want this missing angle. Okay, but I notice that these two sides are the same. Okay, so that means this would be, I believe, an isosceles triangle, meaning two sides are the same. Okay, well, if these two sides are the same length, that tells me that these two angles are the same degree. Well, so there are two missing angles. So I'm going to do this with an equation. I'm going to go, okay, there's two angle y's because they're the same size, plus the 370 is supposed to equal 180 degrees. Okay, I'm going to solve this like a two-step equation. I'm going to subtract 37 degrees. So 2y now equals 143 degrees. I'm going to divide by 2, and I find out that the missing angle is 71.5 degrees. So it's that angle, and it's that angle. So again, you needed to remember that the angles in a triangle add up to 180. All right, number 26, a little bit of intermediate algebra. Determine the equation. Okay, we're going to cross this off and we're going to say determine the slope of the line that goes through those 2 points. Okay, we're just going to do slope. All right, so here we go. So remember, slope is y2 minus y1 over x2 minus x1. I'm going to label my points. This is x1, this is y1. This is x2, this is y2. So here we go. So the slope equals 3 minus 6 and negative 5 minus negative 2. And don't forget, a minus a negative becomes a plus. So the numerator is negative 3 over the denominator, which is negative 3, and that becomes just a 1. So the slope of the line going through those 2 points is positive 1. Okay, number 27, factor out the greatest common factor. All right, so greatest common factor means, okay, what does that mean? Pull out the biggest number they have in common. And the variable they have in common. Okay, well, this is a negative 2. This is a minus 50. Well, what goes into negative 2 and what goes into negative 50? Negative 2 does. So we're going to pull out a negative 2. So what I'm actually doing is I pull out a negative 2. So what I'm doing is I'm actually dividing by negative 2, but I pulled it out. So the negative 2's cancel. Okay, whoa, let me back up. Now I need to look at what x value they have in common. Okay, so let me do this. Okay, now what x value do they have in common? I look x to the third x. They only have one x in common. So I'm going to pull out a negative 2x. Now, when I pull out a negative 2x, I only have x squared left, and I have a plus, because a negative divided by a negative is a positive, 25. So I factored out the greatest common factor, negative 2x, which leaves me with x squared plus 25. Look at that one again and think about how I did that. If you want to check it, you can go backwards and do the distributive property, and you should get the problem back. Okay, last one. A solution to a linear inequality in 2 variables is or are what? So, is it all the points on a line? Is it a half plane, a segment on the number line, or a ray? Okay, well, here's a visual of it. So here's the coordinate plane. If I graph a linear inequality, so you might have a line like this. So I graph the line, and then because it's an inequality, you would shade it. So like I might shade this part if I shade below the line. Okay, well, look at what I just drew. Is that all points on a line? No. Is that a segment on a number line? No. Is it a half plane? Yes. Okay, it's not a ray. So yes, it's a half plane. Okay, there's a lot of material here. Study, study, study. Go over it. Watch this again if you need to before the test. All right, good luck.